Hello, in this video, I will explain to you on how to solve this problem here. Find the currents I1 and I2 and the power absorbed by the 40 kilo ohm resistor. So we will have this one here as I1 and then we have this one as I2. Okay, and I think I will do KCL at this node here. Let's name that node as node A, so the voltage here will be VA. Right? But then we need a reference node. A reference node is the node where we assume that the voltage there will be 0. So this is the reference node, or some other textbooks call it ground. And what does that means is the voltage here will be 0. Good. And now let's see the direction of the current. I1 is going up and eventually it will goes to the right, right? And this is a current source, so we just follow the arrow direction, so it will be going down here. And here we have I2, which is going down, and it comes from here, which is going to the right, right? Okay, now what we can do is we can do KCL at node VA. Let's do exactly that. KCL at node VA, the Kirchhoff current law. Okay, what does KCL say? KCL said that the sum of the currents that goes in will equal to the sum of the currents that goes out. Okay, let's see here. The only current that goes in is this one, which is I1. Right, so I will write I1 here as the only current that goes in. And we have done here for all the currents that goes in. And there are two currents that goes out. We have this one and that one. And we start from this one first. And we exactly know how much this current is, which is 16 milliampere. So we will have this one will equal to 16. And then plus this current here, which eventually goes here, which is I2. Good. So I1 is 16 plus I2. But then what can we do from here is one of the more important things. So here I1. How can we calculate I1? We know this will go through this 40 kilo ohm resistor. But we know Ohm's law, right? We can calculate current from the voltage and resistance, right? So I1, current is the voltage divided by resistance, right? So what is I1? I1 will be some voltage divided by the resistance. But which voltage? Okay, let's see I1 here. I1 comes from this node here, which is the voltage is 0. So we write 0 first. And then it goes to this node here. So it goes to VA. So we subtract VA from it. 0 minus VA. But then remember that this is a voltage. To get current, we need to divide by the resistance. And the resistance is this one here, which is 40 kilo ohm. So I will have 40. But how about the kilo ohm? Do not worry about that, because if VA is in volt, 40 kilo ohm is 40 is in kilo ohm, the I will be in milliampere. So we don't have to worry about that. So we will have I1 here is equal to minus VA divided by 40. Good. And now we can do same thing here for I2, right? So we'll have I2. Now what is I2? I2 comes from this node here. So VA came first, so we'll have VA. And then it goes to this reference node, right? It will pass through this 120 kilo ohm resistor and it goes to this node here. So I will have minus 0. But remember, this is a voltage. We need current. So we need to divide it by the resistance, which is 120. So we'll have 120. So we will have VA divided by 120. Okay, that's good because we have all the values needed from here. I1 here is minus VA over 40. So let's do that, minus VA over 40. And that will equal to, we will have 16, and then plus, what is I2? I2 is VA over 120. So I will have VA over 120. Okay, now let's multiply both sides here by 120. Why? Because it will cancel out all the denominator, right? 40 and 120 will cancel into 3. So I will have minus 3 VA. And that will equal to, I think I will just write it 16 multiplied by 120. And then we will have plus VA here. So I will have plus VA, yeah, because 120 and 120 will cancel each other. So I will have VA here. Okay, move around. So I will have minus 4 VA is equal to 16 multiplied by 120. So we'll have VA is equal to 16 multiplied by 120 divided by minus 4. Okay, so we will have 4 and 16 will cancel into 4. So I will have 480 divided by minus 1. So I will have VA here is equal to minus 480. The unit here will be in volt. But then that is not the question is asking us. It's asking us about I1 and I2. But we already know I1. So let's just plug that in. So I will have minus of minus 480 divided by 40. Here we will have 480 divided by 40. And I think we will have 12 milliampere for this. So we get the value of I1, which is 12 milliampere. Okay, that is good. And now what is I2? We can just plug VA here, right? So we will have minus 480 divided by 120. Okay, and that will resulting in minus 4 milliampere. So we have the value of I2, which is this one here. Good, I have this value, I1 and I2. But then the question is asking us also about the power absorbed by 40 kilo ohm resistor. So we can calculate that P of that 40 kilo ohm. That will be, I think I just use the formula I squared. So that is I1 that passed through here. I1 squared multiplied by the resistance, which is 40. And so we will have I1 is 12 milliampere. So I will have 12. Let's just use SI unit here. So I will have 10 to the minus 3 and then squared and then multiplied by 40 kilo ohm. Yeah, that is kilo ohm. So I'll have 40 multiplied by 10 to the third power. So the unit will be in watt, right? Okay, let's just use calculator for that. I will have 12 multiplied by 10 to the minus 3 and then squared and then multiplied by what? 40 times 10 to the third power. Okay, and I have 5.76. And because we converted into SI unit, the unit here will be in watt. Okay, so the answer is 5.76 watt, which is this question here. Okay, I think that's all for this problem. Thank you for watching. See you in the next video. Bye bye.